The rocket industry just had its iPhone moment, and competitors are terrified. SpaceX didn't just build another rocket, they broke physics itself. While Boeing throws away $100 million with every launch, Elon just cracked the impossible code. A rocket that lands with its staging ring still attached. This Soviet-inspired V3 design? It's already solved the exact problem that killed flights 7 and 8. Those mysterious engine failures? Gone. The lattice structure lets exhaust breathe freely, while competitors suffocate their own engines. But here's the bombshell that has NASA executives in emergency meetings. SpaceX is scaling to 1,000 rockets per year. Mars colonization jumps from 5 missions to 500 missions by 2033. Traditional aerospace just became the flip phone industry. Let's dive right in. Picture this moment. Engineers at Starbase watching their screens in horror. Flight 7, gone. Flight 8, another catastrophic failure. Billions of dollars, literally exploding in their faces. But here's what nobody saw coming. The failures weren't random. They weren't bad luck. They were being murdered by their own design. The killer, something so embarrassingly simple that traditional aerospace engineers are still in denial. The hot staging ring was choking Starship's engines to death. Think of it like this. You're a world-class sprinter, but someone keeps putting a plastic bag over your head during the race. That's exactly what was happening to those Raptor engines. The old V2 staging ring had these pathetic little vent holes, like trying to breathe through a cocktail straw while someone's shooting a flamethrower at your face. Hot exhaust couldn't escape fast enough, creating deadly back pressure, suffocating the second stage engines right when they needed oxygen most. 2 multi-billion-dollar rockets, dead because of holes that were too small. But while NASA was still playing detective, Elon was already sketching something that would make 1960s Soviet engineers rise from their graves and applaud. Here's where this story gets absolutely insane. Remember the N-1 rocket? The Soviet Union's spectacular failure to beat America to the moon? 4 launches, 4 explosions, the biggest fireworks show in space history. But buried in that wreckage was one brilliant idea that everyone ignored for 60 years. The N-1's jettison mechanism, a design so ahead of its time that even the Soviets couldn't make it work properly. Until now. SpaceX didn't just study the N-1. They perfected what killed the Soviet space program. The new V3 hot staging ring looks like something from another planet. Instead of a solid ring with tiny breathing holes, it's a lattice of zigzagging struts creating massive exhaust highways. Hot gases now stream freely downward, like a waterfall through a canyon, not a trickle through a clogged drain. But here's the part that's making Boeing executives wake up in cold sweats. This isn't just about better airflow. SpaceX just committed the ultimate heresy against 60 years of rocket industry gospel. Every single rocket company on Earth throws away their staging hardware after each flight. Let that sink in. It's like buying a brand new Ferrari, driving it to the grocery store once, then pushing it off a cliff. Absolutely insane. But that's exactly what the rocket industry has been doing since the 1960s. SpaceX just said, "We're done with this madness." The V3 ring doesn't detach. It doesn't get jettisoned. It doesn't become expensive ocean debris. It stays connected to the booster during landing. This single change eliminates millions upon millions of dollars in discarded hardware per flight. While Blue Origin and ULA are still fishing rocket parts out of the Atlantic Ocean, SpaceX lands with everything intact. Think about the economics here. A traditional rocket launch costs $100 to $400 million, partly because you're literally throwing away a skyscraper's worth of engineering every single time, the equivalent of demolishing the Empire State Building, just to deliver a package. SpaceX just flipped that equation upside down and inside out. But the real genius, this isn't just about saving money. The V3's taller profile creates a protective fortress that extends higher above the booster dome. Previous versions? Those scorching exhaust flames were literally licking the grid fins, those crucial steering surfaces that guide 20-story rockets back to Earth. Flight after flight, these fins got torched, scarred, damaged. It's like trying to steer a car while someone's blowtorching your steering wheel. The new design, grid fins stay cool, clean, undamaged. Perfect steering control every single time. But manufacturing? This is where SpaceX shows their true genius. The old rings required dozens of complex welds, intricate plate seams, extensive post-flight rebuilds that took weeks. The V3's modular lattice structure? Each strut is completely self-contained. Damaged section? Swap it out in minutes. Not months. Lower turnaround time between flights. Dramatically reduced maintenance costs. The two holy grails of commercial spaceflight, achieved with one stroke of engineering brilliance. But SpaceX wasn't done breaking industry minds. SpaceX isn't just building better rockets. They're building a rocket factory that makes Toyota's assembly lines look like a kindergarten craft project. The new Gigabay facility, replacing the old high bay at Boca Chica, is designed to manufacture 1,000 Starships per year. 1,000 complete rocket systems. That's nearly 3 full rocket assemblies rolling off the production line every single day, including weekends. Traditional aerospace? They build maybe a dozen rockets annually, treating each one like a handcrafted Rolls-Royce. SpaceX is targeting industrial-scale production that would make Henry Ford weep with joy. But here's the question that's keeping space agency directors awake at night. Why such absolutely insane volume? Because SpaceX isn't planning to visit Mars. They're planning to build a civilization there. Buckle up, because SpaceX's colonization timeline just made every government space program look like they're moving in slow motion. 2026-5 uncrewed Mars landings, each carrying 10 metric tons of equipment, testing the waters. 2028 to 2029, 20 missions annually, 75 tons each, building the foundation for human survival. 2030 to 2031, 100 missions per year, 150 tons per flight. Large-scale base construction begins. 2033, 500 missions annually, 300 tons each mission, 500 interplanetary flights in a single year. That's not exploration anymore. That's migration on a species level. That's humanity becoming a multi-planetary civilization, whether Earth governments are ready or not. But here's the question nobody in traditional aerospace wants to ask. How do you fuel 500 interplanetary flights per year? SpaceX's master plan hinges on something that sounds like pure science fiction. Gas stations in space. Here's the physics problem that's stumped rocket engineers for decades. Starship can't reach Mars fully fueled from Earth. The rocket equations simply won't allow it. Too heavy, too much fuel needed just to escape Earth's gravity. But launch a Starship into Earth orbit, then send up multiple fuel tankers to top off the tanks? Now you're talking interplanetary range. The V3 design makes this orbital ballet possible. Automated docking, cryogenic fuel transfer, multiple refueling cycles, all happening 400 kilometers above our heads while people are stuck in traffic jams below. Traditional rockets can barely reach orbit once and throw everything away. SpaceX is building a space-based logistics network that would make Amazon's distribution system look primitive. Orbital fuel depots, automated tanker fleets, interplanetary supply chains. But the real strategic genius? They're not stopping at Mars. While NASA burns through budgets on single Artemis missions, SpaceX is quietly planning Moonbase Alpha, the first permanent lunar settlement. But this isn't just about planting flags and taking photos. The moon becomes humanity's first off-world shipyard. Low gravity makes it the perfect place to construct massive interplanetary vessels that would collapse under Earth's gravity. Mars colonization becomes exponentially easier when you're launching from the moon's surface instead of climbing out of Earth's gravity well. It's like building a harbor before you launch your naval fleet. Strategic brilliance disguised as ambitious dreaming. But here's what has Boeing, Blue Origin, and ULA executives truly panicked. Meet Raptor 3, 16,000 seconds of ground testing across 300-plus firings. This isn't just an engine upgrade. This is a complete reimagining of rocket propulsion. Simplified plumbing, integrated cooling loops, exposed mounting that eliminates bulky protective covers. The new Starship will carry 9 of these mechanical beasts, each more powerful and reliable than anything currently flying. But engine count isn't the real story. It's what these engines enable. Rapid reusability without extensive refurbishment. Land, refuel, launch again. The airline model applied to space travel. Boeing's Starliner took 6 years and multiple catastrophic failures to reach orbit once. SpaceX is building systems designed for daily operation. Like city buses, not museum pieces. The V3 booster trades its old grid fin configuration for 3 larger, more efficient control surfaces. Why does this matter? Grid fins are basically air brakes with steering capability. Bigger, more efficient fins mean more precise landings with less fuel consumption. Every gram of fuel saved on landing is a gram available for payload delivery. The repositioned fin mounts sit farther from the hot staging inferno, eliminating thermal damage that plagued earlier versions. Clean fins equal precise control. Precise control equals successful recovery. It's optimization at the molecular level, applied to systems the size of Manhattan skyscrapers. While SpaceX perfects V3, what exactly are their competitors doing? Blue Origin's New Glenn still hasn't flown after years of promises. ULA's Vulcan managed exactly 2 flights in 2024. Europe's Ariane 6 launched once after a decade of delays. China's rockets remain mostly expendable throwaway systems. SpaceX isn't just ahead. They're operating in a completely different universe, playing by rules they invented themselves. The V3 represents more than technological advancement. It's proof that American private industry can innovate faster than government programs, foreign competitors, and traditional aerospace giants combined. But here's the most shocking revelation of all. This is just the beginning. SpaceX has promised deeper dives into orbital refueling systems, advanced heat shield technology, and ship-catching mechanisms that make the current Mechazilla look like a children's toy. V3 isn't the destination, it's the vehicle for an even more ambitious journey. The question isn't whether SpaceX will dominate space launch anymore. The question is whether traditional aerospace can survive what's coming next. Because right now, watching SpaceX's V3 development, it looks like the entire industry just became the blockbuster video of space transportation. And we all know how that story ended. So here we are, watching SpaceX rewrite the laws of physics while traditional aerospace companies are still using fax machines. The V3 isn't just a rocket upgrade, it's humanity's first real step toward becoming a spacefaring civilization. Every zigzagging strut, every integrated component, every production milestone is building the bridge between Earth and the stars. But here's what keeps me up at night. If SpaceX can revolutionize rockets this dramatically in just 5 years, what happens when they perfect orbital refueling? When they crack the code on Mars terraforming? When they start building ships directly in space? We're not just witnessing the birth of better rockets. We're watching the moment our species graduates from planetary infancy. The real question isn't whether SpaceX will succeed, it's whether we're ready for what success looks like. 1,000 rockets per year, cities on Mars, humans scattered across the solar system. That future just got a lot closer, and it's arriving faster than anyone expected. What do you think happens next? Are we ready for a multi-planetary civilization? Or are we about to bite off more than we can chew? If this blew your mind like it did mine, smash that like button and subscribe to Space Core. We're diving deep into SpaceX's orbital refueling secrets next week. And trust me, you won't want to miss what we uncovered about their Mars fuel depot plans. Drop your thoughts below, because this conversation is just getting started.